So the next topic is escape velocity. What is escape velocity? Escape velocity क्या है? See, if you take a ball and throw it in the upward direction, then what happens?
It comes back.
After going to a certain height, it comes back. If you throw it harder,
Harder.
और थोड़ा ऊपर जाएगा, फिर नीचे आएगा. So मान लो you have a ball and you can throw it with any velocity you feel like. जितना चाहे velocity से तुम इसको throw कर सकते हो. ठीक है? So if you throw it with a certain velocity, जिससे वो तब तक वापस ना आए जब तक वो infinity तक ना पहुंच जाए, तो क्या वो वापस आए? अगर वो infinity तक चला जाता है, तब gravitational force कितना हो जाएगा? और खींच पाएगा वो ऑब्जेक्ट को ना? So this will go away. It will never come back. This minimum velocity with which you should throw an object so that it never comes back to the earth is called the escape velocity. अब वो निकालेंगे कैसे हम लोग? बहुत सिंपल सा एक concept से, conservation of energy principle. ठीक है? So write this down. Escape velocity is the minimum velocity. Escape velocity is the minimum velocity with which a body should be thrown. Minimum velocity with which a body should be thrown from the surface of Earth. So that it never returns back. So that it never returns back to the earth. Never returns back to the earth. Clear? Orbit no है. Field के बारे में. Gravitational field के बारे में. Now, if we apply conservation of high energy principle, because these are all what force? Conservative force here. So we can apply conservation of energy principle. Applying conservation of energy, total mechanical energy at surface of earth is equal to total mechanical energy at infinity, right? So tell me, total mechanical energy from the surface of earth when you are throwing it, it is having both tangential potential and potential energy, and potential energy is G mm by R, right? Where capital M is mass of earth, small m is the mass of the object, and R is the radius of earth. क्यों? क्योंकि earth का surface से throw किया जा रहा है ना, तो earth का surface में the distance between the object and the earth is the radius of earth. Now, total mechanical energy at infinity. So if you are throwing with minimum velocity, then at infinity the velocity will become zero. So if the velocity becomes zero, kinetic energy becomes zero. And you know, at infinite separation, we have chosen the potential energy to be zero. So we can write half mv square equal to, so v equal to root over of, this is called escape velocity. That means if you give this much velocity up to an object and there is no air resistance or anything, it will never come back to earth. So if you put the values of G, M and R, this comes out to be nearly 11.2 kilometer per second. That means if you throw an object with this much velocity from the surface of earth, it will never return back to the earth. But remember, neglecting air resistance. Since air resistance is present, you have to throw with much higher velocity so that you can overcome the air resistance. So, now look at this very carefully. This is the expression for escape velocity. So you understand this is the minimum amount of velocity that has to be given to a body to go to infinite separation. अब एक चीज बोल रहे हैं, rather पूछ रहे हैं, थोड़ा आंसर दो मुझे. अगर हम लोग कोई एक ऐसा प्लैनेट में जाते हैं जिसका मास अर्थ से बहुत ज्यादा है, और रेडियस अर्थ से बहुत कम है, तो वहां पर एस्केप वेलोसिटी ज्यादा होगा या कम होगा? बहुत ज्यादा होगा. If such a situation occurs that escape velocity becomes greater than, right, you know, c is what? Speed of light. 3 into 10 to the power 8. Now, why?
Hi. Hi.
Right. When the escape velocity becomes greater than the velocity of light, then not even light can escape that planet or that object.
Wow.
You call it black hole.
So that wormhole?
Wormhole is a different concept. So, if escape velocity becomes greater than c, then even light cannot escape the field. Then it is called a black hole. So ब्लैक होल ऐसे ही फॉर्म नहीं हो जाता है. इन जनरल ब्लैक होल का जो फॉर्मेशन होता है मोस्टली वो स्टार्स से, डाइंग स्टार्स से बनता है. ठीक है.
Supernova, right?
So what happens whenever a star like our sun is a star, right? So whenever a star it ends the life cycle means एक स्टार में एनर्जी कहां से होता है? मालूम हो गया है. हाइड्रोजन फ्यूज करके हीलियम बनता है and that creates a huge amount of energy. So what happens gradually the hydrogen will be get used up,
Yes.
and when they form helium
Helium.
they also try to form higher lithium, beryllium, boron, carbon. They start forming them. So as they start forming them and gradually the hydrogen finishes, the star comes to an end.
And
So initially the star is like our sun, which is at a very young stage. This is called the yellow stage, which is young stage. Finally it becomes a red giant. Red giant is the final stage, and after that it starts collapsing because of its own gravitational force. Now once it starts collapsing, its radius decreases very quickly, but the mass does not change.
yes.
So if the radius change, when the radius is decreasing, if somehow it becomes so less that the escape velocity becomes greater than 3 × 10⁻⁸ meter per second, it turns into a black hole. So these dying stars, they can turn into black holes. बना सकते हैं, ऑब्वियसली बना सकते हैं. Concentrate कर करवा के बना सकते हैं. But the problem is, once a black hole formation take place, it will absorb anything which is in its gravitational field, and that field extends up to event horizon. Once you cross event horizon, there is no turning back. पीछे नहीं आ सकते. It will absorb it into its gravitational field, and you come into a singularity.
And then what happens after that? After we
Nobody
enter
will
the black
see.
hole.
When if somebody enters a black hole, then his formation will not be right. Why?
Collapse.
Because his speed will increase so much that, according to the theory of relativity, the sizes will change, and we may not be in our form at all. हमारे নিজেদের ফর্মই না থাকতে পারে.
স্পিডে গেলে স্যার চামড়া ফামড়া উঠে যাবে।
হ্যাঁ